Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our first video on using Venn diagrams to solve probability questions. To start with, you need to be really good at populating Venn diagrams. So, pause the video and double check you can answer this question using a Venn diagram. Okay, this is the answer here. Now, I'm not going to go through this particular question. I have done that previously in the Venn diagram section, so do go back to your building blocks if you're not familiar with what's happening on this page. Now, this question is going to be phrased in a probability style question. You're going to be asked something of the following. Imagine the student is chosen at random. What is the probability the student studies art? Given the information above, you may draw a Venn diagram. Use that to find out how many students in total study art. Here we find there are 24 students, and we know in total in the class there are 45. So the answer to this would be 24 out of 45, which you can simplify, dividing top and bottom by 3 to get 8/15. So these are the styles of questions we're going to be answering. A probability style question, and we'll use Venn diagrams to count how many people in each type of set. So let's get on and try one straight away. Pause the video and have a go at this question. So here we've got a class of students playing football or in the choir or both or neither. So this is a classic case of using a Venn diagram, and down here we're asked various probability questions. So let's start as always by drawing this Venn diagram. Now why don't I label one circle capital F for football, the other capital C for choir. I know the number of elements in my universal set are 31. And let's see if we can use the rest of the information in the question to populate this Venn diagram. Well, the key fact here, a really crucial fact, is that 5 both play football and are in the choir. So 5 go in this overlap, or what we call intersection. Let's see if we can go through the other piece of information. 15 are in the choir. Now 15 in total will be in this circle, but given 5 we've already placed in the intersection, which is in the circle, how much must be just in the choir and not play football? Well, we would do 15, subtract this 5 to tell us that there are 10 there. So then we can clearly see that the 10 and the 5 add to the 15 that are in the choir. What about the fact that 7 play football? Well, given that 7 play football, 7 in total must be in this circle. 5 are already here. We would do 7 subtract 5 to get 2, and that means there are 2 students who play football who are not in the choir. Now we do need one more piece of information to complete our Venn diagram. How many students neither play football nor are in the choir? Well, it would be something we write out here. How would we work that out? Well, we know in total there are 31 students, and if we add these up, 2 add 5 is 7, add the 10 is 17. If we were to do 31 subtract the 17, which is 14, that must tell us that 14 students neither play football nor are in the choir. And that is our complete Venn diagram. Now any probability question we're asked should be relatively straightforward, so let's have a go. A student is chosen at random. Find the probability a student is not in the choir. Let's highlight people that are not in the choir. That's everyone outside the circle. So in particular, it would be these 2 students and these 14 students. So therefore, the probability of choosing such a student would be 16, the 2 add the 14, out of a total of 31 students, and we've done. Okay, next one, let's have a go. The next one says, the probability a student plays football and is in the choir. Well, let's label the students that play football and are in the choir. They're in this intersection here. There are 5 of them, and there are 5 of them out of a total of 31 students. Okay, and we're done. Right, next, the probability a student does not play football but is in the choir. So let's label all the students who are in the choir but don't play football. So these students here, you can see, are certainly in the choir, but they do not play football. So there are 10 of them out of a total of 31 in total, and we're done. Next, a student does not play football and also is not in the choir. Let's think about that. Where would the students be who don't play football and are not in the choir? Well, they'd be these students outside, wouldn't they? These 14 students don't play football and are not in the choir. So it would be, in total, 14 out of 31. And drawing our Venn diagram made those questions very, very straightforward. Okay, the last one, slightly trickier. Let's have a think about this. Given one student at random plays football, what is the probability they are not in the choir? So we are given a fact here. This given is a key word. We are given a fact that one of the students at random plays football. You select the student at random. They are the students that play football. So what we do in this case is we think of all we're interested in is these 7 students here who play football. It says what is the probability they are not in the choir? So you're asked here, what is the probability out of those 7 students that they're not in the choir? Well, 5 of them are in the choir, these 5. 2 of them are not in the choir, these 2. So out of the 7 you're interested in, 2 of them are not in the choir, so the answer must be 2 out of 7. Okay? Right, why don't we try another question? Pause the video and have a go at this. Okay, let's draw the Venn diagram as before. And our first fact is that we have 40 students in the class, so the number of elements in our universal set are 40. We are told 13 play football but are not in the choir. Let's label this capital F, this capital C. 13 play football but are not in the choir. 13 must go in this section here. That fact has been used. 15 are in the choir but do not play football, so 15 must go over here. And 5 students neither play football nor are in the choir, so 5 students are outside. The only piece of information we don't know, and this piece of information is always the crucial piece of information, is how many students both play football and are in the choir. So let's call it X. We know for sure that if we do 13, add X, add 15, add the 5, it must add up to 40, the number of students in the class in total. So let's do that and solve for X. And when we do that, we get ourselves that X must be 7. Now we've got all the pieces of information we need to answer any question on probability. Let's have a go. Given that a student is chosen at random, find the probability a student plays football and is in the choir. So we know now there are 7 students who play football and are in the choir out of a total of 40. So we can just state the answer like that. Next it says find the probability a student does not play football but is in the choir. Let's label those. So does not play football but is in the choir. These students here are in the choir but they do not play football. And how many of them are there? Well, there are 15 of them out of a total of 40 students in total. We can divide top and bottom by 5 to get ourselves 3/8 as a simplified fraction. Okay, next one. Find the probability that a student is not in the choir but does play football. So we're looking for the students who play football but are not in the choir, so they are these 13 students here. So our answer in this case would be 13 out of 40, which we can't simplify any further. Right, the last question. Given one student at random is in the choir, so you've taken one student and they are in the choir, so you're interested in these students, these 15 add 7's 22 students. What is the probability they do not play football? Well, 15 of those students of those 22 don't play football and 7 out of those 22 do, so the probability in this case is simply going to be 15 out of 22, and we're done. Okay, last question. Pause the video and have a go. Okay, let's have a go at drawing this Venn diagram. We're told in a year group there are 180 students, so the number of students in the universal set is 180. Now 130 eat fish. Let's label that capital F for fish and maybe capital M for meat. 70 eat meat, 40 eat neither. The only piece of information we can really put in at the moment is 40 outside. We don't know the information that's really crucial to us, how many people both eat fish and eat meat. There must be people that eat fish and eat meat because the 130 add the 70 adds to 200, which is more than the number of students in total. So there is some overlap. We don't know it, so why don't we call it X? What should we write here? Well, in total we know that 130 students eat fish, so this whole circle must add up to 130. The portion outside must be 130, subtract this overlap, which is X. And similarly, we know that 70 eat meat, so 70 in total are in this whole circle here. So what are we going to put outside for the students who eat meat but don't eat fish? Why don't we write 70 subtract X like that? Alright? Now that is a useful labeling of the diagram because we know for sure now that if we add this, this, this and this, it must add up to 180. So let's write that equation up here and solve it for X. And we get ourselves that X must be 60. So now we can label this diagram. If that's 60 there, this must be 130 subtract 60, which is 70, and this must be 70 subtract 60, which is 10. Now we do have the Venn diagram in the way we want, and any question should be straightforward for us. So we're told a student is chosen at random. Find the probability the student eats fish and meat. Well, there are 60 students who eat fish and meat out of 180, and that simplifies dividing top and bottom by 60 to a third. Find the probability that the pupil eats fish. There are 70 such pupils out of 180, which simplifies dividing top and bottom by 10 to 7/18. Only meat, 10 out of 180, dividing top and bottom by 10 simplifies to an 18th. Who eat everything except meat? Well, they're the students who eat everything outside of the circle of meat. So it must be these 70 and these 40, which would be 110 out of 180, which simplifies to 11/18. And last one, given that one person at random eats fish, so we are interested in this section here, these 130 students, what is the probability they also eat meat? Well, 60 of those also eat meat, so it must be 60 out of the 130, which simplifies to 6/13. And that's it for this video. Thanks loads for watching.